This is 7-87 integrated 1, and it had us graph this quadrilateral ABCD, and then it says, Tamika heard that the diagonals of a rhombus are perpendicular to each other. Help her test her conjecture. So we already graphed it. A rhombus has 4 sides that are of equal length. Is ABCD a rhombus? Show how you know. So do we know a way to find out if all these lines are equal length? Like, do we have any ideas on how we could prove that? Besides, not by going and measuring it, but some other way we can find out. Now, I already see something, because I remember the last problem that we just did. I think I can try to prove AB and DC have equal length, because I think I can use Pythagorean theorem on them. Because watch. Right? I mean, that should work, right? If this is 2, and this side's also 2, which it is, that's good. See, that side's 2 and that side's 2. And if these bottoms match, I don't even have to do the hard work of figuring out what the length is. I can just, I'll know. 1, 2, 3, 4. Is the bottom 5 also? Yay! So if this is 2 and this is 5 and this is also 2 and this is 5, they have to be the same length because Pythagorean theorem. You know, when I work it out, a squared plus b squared c squared. So do I have to work it out? That's the question. Oh wait, let's do it. Can we do it on the other ones? The other ones we can do it too, I think, because this is 2 and this is 1, 2, 3, 5. Are the other ones the same? 2, 1, 2, 3, 4, 5. I think I've proven it's a rhombus. It says show how I know, so I guess I better just use Pythagorean theorem. I'm kind of lazy that way. But I'm going to say these slope triangles I've drawn for each of the 4 lines, they all have 2 and 5. So I'm just going to do it for one of them. Let's get this thing to go away. So 2 squared is 4, and 5 squared is 25, and that's equal to c squared. So that's not very nice, it's 29. So to solve that using algebra, to unsquare the c, I would just square root both sides. Now if you push your square root button on your calculator, you're just going to get probably a horrible looking decimal. So you can leave it as root 29 if you want. That's pretty much me showing, because I've shown the slope triangles, I've shown the math. I know that all of these 4 sides are all root 29. So I think that's sufficient for letter A. Letter B says, write the equations of the lines on which the diagonals lie. That is, write the equations of AC and BD. I know somebody besides me is going to be able to write these equations of these lines. I'm pretty happy about that. Who knows how to find the equation of this red line that I just drew? Sandy.
You get the y-intercept at 5, and it's going down to the negative, well, negative 1.
You think it's negative 1?
Yeah.
Yeah, it looks like it. Good. So I think that the equation of AC is right here, negative x plus 5. And then, okay, so Rocco, do you want to do the other one?
Okay, wait just a second. I have to write down this answer. What's the next one?
It's the green line.
BD.
BD.
Y equals, let's see, so it looks like it starts the origin, so B is 0. And it's going up one at a time, so since they're it looks like they're exactly, looks like they're perpendicular.
They are, and we know things are
that means that y equals x.
Yes, because it'd be y equals 1x plus 0, but we can just write it as y equals x. So these are the 2 equations, the lines. I know it's hard to read the green, but I color-coded mine. So we're supposed to know, and I hope that we mentioned this yesterday, we're supposed to know that if the slopes are opposite reciprocals, then the lines are perpendicular. We learned that in the beginning of the year, and then we talked about it a little bit yesterday. So, -1 is the slope of the red line, and +1 is the slope of the green line, and those are opposites, and the reciprocal of 1 is 1, so they're opposite reciprocals.
And
So-
we just answered part C.
Yeah, so it just said write equations for B. So this is B, my two equations are written here. And then C would be, compare the slopes, what do you notice? And then, so you're gonna say, -1 and 1 are opposite reciprocals. That was a good question to ask. And so when we say that, we can say therefore, the diagonals, because that's what those lines are, they're the diagonals of the rhombus, the diagonals are perpendicular. And that was what they asked at the beginning of the problem. This Tomika gal was trying to see if she could prove that these lines are perpendicular.